number 18 says, use the information to determine the enthalpy of reaction for this reaction. So we're given CH4 plus Cl2 yields CCl4 and 4HCl. It's 4Cl2. And we're given the enthalpy of formation in kilojoules per mole for CH4, Cl2, and HCl, so everything except Cl2. So essentially what you have to remember here is enthalpy is a state function. So if we know the enthalpy of formation of the products and reactants, what we can assume is we take the reactants and we destroy them and turn them back into their elements. We then take those elements and form the products using their enthalpies of formation. So we essentially want the negative of the enthalpy of formation of the reactants, because we're not making the reactants, we're destroying them, and we want to add that to the positive of the enthalpy of formation of the products. Now, that seems, complicated, so there's a simpler formula for this, which does exactly what I just said. And that is the delta H of the reaction is equal to the summation of N times the enthalpy of formation of the products, so the positive value for the products, minus the summation of N times the enthalpy of formation of the reactants. And here, you're taking the negative of the reactants. We're destroying the reactants, taking the negative, and we're forming the products. Note that N is here, and N is the number of moles, because as we just talked about in the previous problem, the enthalpy of formation is the formation of 1 mole. Well, if we're forming 4 moles, it's going to be 4 times as much. So let's take a look at this. We're starting with the products. The first product is CCl4, and there's one of them. So we plug in minus 96 kilojoules, okay, which I just found right there. Plus 4, because there's 4 HCl's, we have to multiply by the number of them, times the enthalpy of formation of that HCl, which is minus 92 kilojoules, which I found right there. Remember, the enthalpy of formation is to form 1 mole of HCl. In the reaction, we form 4. So we have to multiply that by 4. Minus the first reactant is CH4, and there's only one of them. So we put in minus 75 kilojoules plus Cl2. Now here's the problem. If we look at the enthalpy of formation, Cl2 is not listed. And the reason for that is Cl2 has an enthalpy of formation of 0. By definition, the enthalpy of formation of elements is 0. So therefore, this is just 0, so minus 75 plus 0, or just nothing. Or even if you want 4 times 0, which is still just 0. All right, so it's still just nothing. So minus 96 plus 4 times minus 92, essentially plus 75. And when you do that math, you find that the delta H naught of the reaction is equal to minus 389 kilojoules, which is choice letter C.